Up next, after we have talked about MAC addresses, and that is a physical address, and it is a very important address, the MAC maybe, okay, which was a physical address. It was written in the hexadecimal language, okay. Red looks good on black background, okay, and it was mandatory, constant, unique for each device, technological device in the world, and for each port of each network device, okay. It is mandatory, it is unique, it is constant, but is it used for identifying the device or for communicating? What are we studying in this course? We are studying networks, we are studying networking, we are studying to establish a network between devices so they can do one thing: communicate or share information, okay. So MAC address is not used really to communicate or share between devices, between network devices, between computers, between servers, even between the camera, the printer, or whatever device you want to connect to the network. Okay, it's correct. All these devices have a unique MAC address, and we have talked about what is MAC address and how it is written and the two halves of the MAC address. But can it be used to communicate? Can a device, maybe computer A, have a certain MAC address? This is computer A, wants to communicate with computer B, which has its own MAC address. Can they together communicate or share through a network, through a specific medium, using MAC addresses? No and yes. What do you mean by no and yes? If you have ever seen half correct, because it's not only related on MAC address, it needs also some other type of addresses, which is called the Internet Protocol address, the IP, the most word that you will hear starting from the day you enter networks until the day you leave networking, if you left this track, okay. So the IP address, which is more difficult, we will simplify, don't worry, more important, has so many specifications and related things and specs that we will talk about, and this is the real address that makes any device in the world talks, that makes any device in the world listens. Whatever type of devices that you have, in case you have a computer, a server, a printer, a camera, a router or a switch, or a firewall, if you remember firewalls and IPS, and whatever device, even the virtualized addresses that we have maybe only mentioned without talking specific about them. We have a subchapter, entire subchapter for virtualization or virtualized devices, virtual machines, okay. All these devices can never talk, communicate, share information, send something, receive something, receive information, do whatever action in network, in any type of networks, without having IP address, okay, the most important thing in the network. So let's just jump and start in talking about IP addresses. Clear the mess. Okay, Internet Protocol version 4, which is the shortcut for it, is IPv4. For you, there is nothing called IPv2, 1, 3, 5. No worry, there is no such thing at all. You only need to care about what is called IPv4, and up next we will have IPv6 to talk about. Okay, IPv4 is one of the most famous and common examples of layer 3 technology. You remember layer 3 if you have studied the OSI layer, the OSI model. Layer 3, okay, the internet, or what's called the, what was called about the internet, okay, layer, I believe, or the network layer, I'm sorry, in the OSI layer. One which was used, one of its most famous or common examples is the IP address, which is transferred using packets, or what is called also IP packets, because whatever thing that travels through layer 3 of OSI should be traveled using packets. Okay, MAC addresses were used to be written using the decimal language and the binary also. You will see how is this possible. Okay, the hexadecimal language, the MAC addresses. Now we have IP addresses using decimal language and binary. Okay, so you will no longer see A, B, C, D, and this way 01 CC and whatever, this complicated method. This is not for you. This is for the devices to be unique and be manufactured with a MAC address. For you, you will see addresses written in only the form of number, so you can preserve it in your mind. It will be only about numbers. But how length? What's the method? Is there a colon just like MAC addresses? You will see upcoming. Okay, decimal language and binary language also, because routers and switches do understand binary in some cases. Again, okay, but they will show you the decimal because it is easier to remark decimal than binary. Why? If you remember, when we had the decimal to binary conversion and vice versa in one of our previous chapters, we said that number 4 is written in decimal as 4 only, but in binary it is written in the upcoming method, which was like 0 0 1 0 0 0 0 0. This is number 4 and this is number 4. What is best to you to recognize and to remember is the decimal form, but this is something that the router shows you or the computer or whatever networking device shows you, but they don't understand it this way. They understand numbers this way only. Okay, so there is always an automatic conversion inside each device just to show for you what you understand, and they will show themselves, the devices I mean, what they understand. So decimal language and binary language is also used for producing IP addresses. After that, we will talk about the logical address. You remember MAC address was a physical address. Why is it physical? Because that address is unique. It's never duplicated. It is not manufactured or edited by us, the end users, the engineers, or the engineers that are using end devices. I prefer to say end users instead of engineers, because engineers are who manufactured MAC addresses, so yes, they can edit it. But us, whatever we are, teacher, a student, or whatever, a network engineer in an organization, all of us are end users, or end users do not edit MAC addresses. That's why it is a physical address. That's it. It's constant and unique forever. IP addresses are logical addresses. They are virtual addresses, not real addresses that are sticky to whatever port or device or whatever thing in networking world. No, it's something temporary. Okay, temporal. It is something that you decided based on a lot of specifications we will talk about in the upcoming slides. It can be removed and changed and edited at any time you want for any reason or cause that you as an engineer want to edit for. This is a huge resiliency for IP addresses based on whatever use you need to make of the device or of the port. Okay, so it is a logical address. It is variable based on the need. MAC addresses were to have a length of 48-bit. This is one of the most important questions in the network exams, the length of IP address compared to the length of MAC address. Now IP addresses has only the length of the 32-bit. How is it written? How do we decide a 32-bit? We will just talk about right now. Let me delete this. Okay, so leave this part. Let us talk about these two parts. A 32-bit and has 4 octets. What do you mean by octet? By octet, I mean only a part. Do you remember how we write it MAC addresses? It was something in this way, and there are colon. After that we have this part, and there is a colon, and finally we had the third part, and they said there is no way for a fourth part in MAC addresses. No matter what happened, there is no way for to be two parts. No, it must be three parts. Each part must be 4 digits, because these three will equal 4 multiplied by 3. How much will it be? 4, I'm sorry, multiplied by 4, it will be 16-bit. Okay, so this is how MAC address should be written, and there is no playing or anything about this. So IP addresses is it's contained, or it's produced out of 4 octets. What do you mean by octet? I mean the part. MAC address has 3 parts. IP addresses has 4 parts. So we have something to write: part 1, 2, 3, and 4. So now we have 4 parts. What's inside the part? Is it hexadecimal language? No, you know it is decimal language, and it will be converted to, this is not clear, to binary language in order for the device to understand it. It's decimal thing happens in here. What's between each part? Is it a colon like MAC address? No, it's only a dot. So I have 3 dots that are separating for me 4 parts. Each part contains inside it a decimal number, which is, please note that whatever number is inside this single octet of IP address, it must be, and it will be, from 0 to 255 only. No exceptions about this, because this is the architectural form, or the architectural method that the IP address was built based on it. Okay, so up until now, what did we talk about? That IP address is written in decimal language, has 4 octets. Between each octet there is a dot, and each octet is written in the decimal language, with using numbers from 0 up to, maybe in this way, maybe in this way, 200, whatever number between 0 up to 255. One last thing is that since the total length of the IP address is 32-bit, and since it will always have 4 octets, then my question in here is that each octet has the length of 32 divided by 4, which will equal to us 8 bits. You know that number 8 in the old Latin language equals to, I believe it was octa, maybe octa was 8, not just 8. So this is where the term octet was derived from, because the size or the length of each part of these 4 parts will always equal 8 bits. Okay, so let me clear this. Okay, so long we have talked about it is a layer 3 technology. It's carried in IP packets. Okay, it uses the decimal language for you and the binary for the device. Now you have to note here, we will have a conversion all over the task. Okay, it is a logical address, not a physical variable based on your need. You are the engineer who specified the IP address. It has a 32-bit length divided on 4 octets. Each octet will have the length of 8 bits. Okay, so let me write here one of the most popular and well-known IP addresses in the world. You might have noticed or read such address before plenty of times, but you had no idea about it, or you do already know about it, which will be 192.168.1.1. This is one of the most famous IP addresses in the world. You can assign or give this address to whatever your device you have, your mobile device, your PC, computer, laptop, server, IP phone, camera, whatever device, you can give this IP address to it. Because is this a correct IP address? Is it contained of 4 octets? Yes. Does it have 3 dots separating them? Yes. Is it contained of numbers that are from 0 to 255? Yes, it is. That makes it a IP address without argue. Okay, so we have talked about all of these, and we have left this note that part of the IP address is for the network, not for you. The other part is for the host. What do you mean by host? I mean the device. Host may be a router, the host may be a switch, maybe a PC, it might be a server, it might be a printer, a camera, whatever device that is using or can be used by a human directly, it is called a host. Okay, so part of the IP address is divided. You remember MAC addresses were divided also into 2 halves. The first half is defined by the OUI, the Unified Organization Institute. The other half is defined by the specific company itself. Okay, so MAC addresses are divided into 2 halves. Each one has a function. IP addresses is also divided into 2 halves, but it will not be equal halves. It will not be divided in this way, half for this way and the other half in this way. It will not be 32 divided on 2. It will not be 60-bit each. No, at all. It will not be this way. This will have dozens and plenty of specification to divide the IP address. We will talk about them all. Okay, what does this mean? We will talk about it. Okay, right here we have some notes about addressing converted from binary to decimal and vice versa. We talked about this. What defines network octets from host octets? Each IP address is divided to 2 halves. Where this line comes here, here or here, I have no idea. We will talk about this upcoming and how we will specify this. Okay, maybe if we divided the IP address this way, the half on the left will be called the network half, the half on the right will be called the host half, as this one we have talked about. The total hosts all around the entire world, how much maximum IP addresses can be calculated around the world, is something that is not of a guessing. It's something constant since the moment that IP address was announced to the world. Okay, IP address has the length of 32-bit, and thus to know how much IP addresses we know, I believe this is some type of mathematics knowledge or science that is called the algorithm, maybe science. This one that has a power of, so if you want to know, it's related to algorithms, as I believe, something I don't remember the English mathematics books, how was it named it, but whatever. Anyway, I'm sorry. Where the IP address has a length of 32-bit, so to know how much IP addresses we can have in the entire world, starting from this IP address 0, 0, 0, 0 up to 0, 0, 0, 1, and then we keep increasing these until we reach the maximum of 255, 255, 255, 255, the biggest and last IP address in the world. How much total IP addresses will be? Number 2, with the power to 32-bit, and it will result to us with this number, you can see it, which is only 4,294,967,296 IP address. This is the huge number of IP addresses in the world, which is not huge at all. These are already used and gone since a long time. IPv4 was introduced, I believe it started modifying and produced in the Second World War, and announced in the 1960s. So all the humans in the world had the right to use an IP address in whatever organization. So it started to be used from in the 1960s up to until now. It's used globally in the world. It's not obsolete really yet. There is plans for making IPv4 obsolete or making it limited to only some organizations or some small networks, because it's no longer enough. The 4 billions and quarter are no longer enough, but it's still used until now, especially in my country. It's used very widely. Okay, so we have talked about these 3 nodes. We will specify the octets for network and for host in detail. We will have dozens of examples on it, and just to know that the maximum total hosts that we can get in IPv4 are 4 billion and quarter. Okay, so that is for the first slide. Up next, we will have subnetting, and we will talk about subnetting in the upcoming chapter, just to avoid making this too long for you. Okay, thank you for watching.